the latest attack vector, writing about cybersecurity concepts or practicing them, practicing security techniques, I keep coming back to the same reality that we are all prime targets. And like the normal traditional ways of being security wise don't cut it anymore. So today I'm going to talk to you about virtualization. Not virtualization not as an abstract security concept, but as a cybersecurity tool, a necessary cybersecurity toolkit that we are all going to be needing to stay safe in this very volatile digital world. So let's dive in because as you all know, the best time to be cybersecurity conscious was yesterday. But the second best time to be cybersecurity conscious is now. So developers are increasingly becoming the first line of defense in every organization and every client project, not just the traditional security roles. Previously or before, to prevent a problem or like to if a problem that might occur, if the possibility of any problem or any vulnerability, we're always looking for the SOC analyst, the cybersecurity engineer, the cybersec guys. Where are they? But now it's no longer like that anymore because cybersecurity is now everyone's responsibility. It all starts from the developer writing secure codes. The normal place that vulnerability starts is when your codes are insecure. You instead of HTTPS, you configured your website to use HTTP. That is where attackers look at first. And also choosing your dependencies wisely. You don't go to any library you see. Probably you see an outdated library. That's the last time that they updated it was in 2005. And like, oh, this stuff is cool, oh, and you want to add it to your projects. Your That is just laying your hands down to any attacker that sees that deems it worthy to break into your system, or testing your code for safety. Not that you wrote something and you yourself you don't understand the code, but as far as it's working, it's working. I know how it's meant to be done. It's not just meant to be does it work. You want to check whether this thing works, so but is it also safe? Did I cover the track very well? Or can they write code into the forms and perform an SQI attack? Or can they commit um an XSS attack into my website or the project I'm working on, and avoiding risky shortcuts. Going to GitHub, getting any kind of scripts, any kind of you don't even know where it's from, and just putting it there. Those are your opening your system up to attackers. So why are developer machines the lucrative ones? Well, as a developer, you have access to if it's a company you're working for or a client, you have access to the source code. Once an attacker gets into your source code, they have access to all the intellectual property of either your client or the company you work for. Imagine a senior full stack developer of which company can we use of Paystack now. A senior full stack developer of Paystack is hacked. That is that is a gold mine for any hacker. You also have access to deployment credentials and build system keys, your GitHub actions, your GitLab CLI, your Jenkins that they use to deploy web apps and deploy projects. Once they get access to these things, they it no longer being security wise because the company or your client is at the mercy of whoever has gotten into the system illegally. In other words, your as a developer, your laptop or your desktop or even your it even goes as far as being your mobile device because there are different kind of attacks that can get to your laptop through your mobile device. Your any of your devices are basically an attacker's gold mine. So what exactly are we trying to evade? We know we are okay, we've already settled the fact that we are the first line of defense. Now, being the first line of defense also means that we are the first targets. As a developer, you are the first target. Let's imagine this. When you download like a random script from GitHub, or you download uninstall that outdated that outdated library that was last updated in 2005, or just randomly clicking anything everywhere, you're potentially giving any attacker, any hacker, a free ticket into your system, not just your system, into your company, into your clients, whatever you're building for your clients. You're giving that person a free ticket. You're potentially giving that person a free ticket. Because once you click on those things, or once you've accessed those things, it could be a ransomware that locks your system, or even locks the organization and asks for ridiculous amount of money. It could be a spyware that's continuously extradites data to the attacker every now and then. All the every single thing that is happening, they have access to the cameras on the system in the organization. So they just keep on taking whatever they need until they decide to, we've had enough, let's strike. Or simple. That is why spear phishing campaign, basically phishing campaigns that social engineer, for those of you who don't know what phishing is like, um, basically what we most of us know as what Yahoo boys do, sending messages via email. That's when you once you click the link, they've gotten access into your system, or SMS, or even through voice calls. So spear phishing campaigns are like they are targeted at senior officials. For instance, Flutterwaves, they can target Flutterwaves CEO, Flutterwaves CTOs, Flutterwaves, all the senior developers in Flutterwave. And once they get into the senior developer system, they've gotten into Flutterwave. Whatever they want to do, they can do it. Clicking on malicious repos that permits supply chain attacks. Supply chain attacks are attacks that once it happens to your system, it can climb up, get into your client's website, get into your company, and basically wreck everything. It's loading itself into everywhere and everything all at once, and it can wreck everything. And once any of these things happens, not only do you lose your reputation, the company you work for lose their reputation, is you're more than likely liable to a lawsuit, and nobody wants to be going to jail. So what is the solution to all these malicious websites and all these malicious GitHub scripts or any of the above? That's where virtualization comes in. Virtualization is just like having a a guest computer or a guest OS or virtual machine, a mini computer running on your own system. Imagine having a MacBook where you can run Ubuntu and run Windows 10 and Windows 11. They are all at the same, all of them at the same time. They are all on that your MacBook. That is where that is basically what virtualization is. It's like a digital lab coat for your code experiments. Anything, some of us are very curious. Curiosity kills the cat, and satisfaction brings it back. We want to be killed and brought back. So instead of being doing of curiosity killing the cat being your main system, curiosity can always kill the cats being your virtual machine, and you can always bring it back. And if you don't, it's like basically virtualization is just like I said, it's just like having a lab coat. And if you you can't carry out a science experiment without a lab coat. So why would you carry out experiment with untrusted code on your system without your digital lab coats? That is virtualization. So, like you can see in the on the slide, virtualization basically works like this. There is the underlying one is the computer hardware, that is your system itself. Then for for regular computers, is after the hardware, you get the operating system, then the application. But in virtualization, you get the operating system, sometimes without the operating system, then the virtualization layer, what we are going to call what we call a hypervisor or hypervisors, then the operating system. So how does virtualization work? It starts with hypervisors. Hypervisors are the foundation or the magic behind virtualization. Without hypervisors, there's no virtualization. Whether it's there are different types of virtualization, whether it's storage virtualization, network virtualization, um, any kind of desktop virtualization like we're currently discussing now. Hypervisors are the foundation of it all. They're also known as virtual machines monitor. They are like a security officer in charge of your VMs. They assign each virtual machine or each virtual operating system different quotas of computer hardware components. Basically, the important components like your CPU, your RAM, your memory, your storage. They split everything. They divide everything smartly and assign each to the required virtual machine. And the thing about hypervisors is that you can always adjust. Let's say today, the Ubuntu that you have as a virtual machine, you need it for an important project that is going to take a lot of work. And initially, you configured it to be like your Ubuntu has 2 gig of RAM, your Windows 10 virtual machine has 2 gig of RAM, and your Windows 11 virtual machine has 2 gig of RAM. But now, what you're about to do with the Ubuntu is going to carry a lot of weight. It's going to need a lot of power. Instead of leaving that at 2 gig RAM, you can maybe minus 1 gig of RAM from each of the other virtual machines and add it here, add it to the Ubuntu. Then when you're done, you just return everything back. Now there are two types of hypervisors. There is type 1 hypervisor or bare metal and the type 2 hypervisors. Bare metal hypervisors are basically um, hypervisors that don't need operating system. These ones, they have direct access to your CPU, have direct access to your RAM, direct access to your storage. You don't need to have Mac OS on the operating system. You can just have sorry. You can just have wait, I need to drink. uh, You can just have the hypervisors running on top of the computer hardware direct. Examples of these are VMware ESXi, the Microsoft Hyper-V, and the Zen server. All type 2 hypervisors are basically hypervisors that require without your operating system, you can't run this one. They are these are most the ones that are very familiar to people in the industry. For example, now the there are some of them are the VMware. Everybody is very VMware is like the industry standard. It's VMware Workstation and VMware Fusion for Mac OS users or MacBook users. And for MacBook users, you can also have like Parallels Desktop. Is this one is just configured only for MacBook. Then, but this the issue with these three that I've mentioned is that you are paid. For VMware Workstation and Fusion, you need to pay about $150 to $200 if you want to get a return. It's just you pay only once though, but you know how it is. Well, for the parallel desktop is about $100. But to get most of these things that you can do on VMware Workstation and VMware Fusion and parallel desktop, you can just get the virtual box for free. Virtual box, though, is a bit less efficient and slower than the others. On the bright side, it's free. You don't need to pay any money. Then there's also VMware Player. VMware Player is like the unpaid version of VMware, but like it's it's not really how would I put it? It's not really giving like that because there's a lot of things you can do with VirtualBox. You can't even do it on VMware Player. For example, taking snapshots. Snapshots are basically a point in time version of the virtual machine, like freezing time. I'll say it's just like when you're playing a video game, you know the way before you fight the boss of a particular level, you can just save the checkpoints and go and fight the boss. Whether you win or you lose, You can always reload and come back to that particular checkpoint. That's exactly what snapshots are. Snapshots, they save your VM the way it was. You can now go in and do whatever you need. And if it breaks your system, wreck your system, whatever it does, whatever, sorry, if it breaks the virtual machine or wrecks the virtual machine, whatever happens, you can always revert back to the um snapshot and it's brand new as if nothing happened. So we are going to now be talking about containers and VM because sometimes people mistake um containerization for virtualization. Now they are very, very similar. Virtual machines fully isolate operating systems in in your own system, on the host system. They have different guest operating systems that are isolated from that can be isolated from each other and isolated from your host system. But on the other side, containers containerization actually what it does is that on the user side of your system, it just takes some user space, basically where the regular desktop where you can go have your browser and everything. It takes some space from there and isolates different applications in containers. So let's imagine like this: you're in a building. A containerization can be like in the kitchen of that building, there are multiple stalls for different chefs. These chefs they have their various utensils and ingredients for whatever they want to cook. But when it comes to virtualization and virtual machines, you're not the chefs are not in the same kitchen. These chefs are in their own kitchens that have their own doors. They don't share the same kitchen. They have their own doors, and nobody you cannot just a chef from the without the right permission or access, a chef from this kitchen cannot come to this other kitchen to cannot communicate with this kitchen without the right permissions. So I'm going to be looking at two case studies of using virtual machines. So the first case study is malware testing. Let's imagine that okay, your deaf friend said that told you about his laptop recently blue screening. And he told you that the reason why his laptop blue screen was that he got a script from GitHub that he wanted to try out on the project he was working on. But he doesn't know what happened after he ran that stuff on his VS Code. His system and he went online with it. His system shut down and blue screen. Now, as you being a very curious guy, you wanted to, guy or girl, you wanted to try this thing out. But if you try it on your regular laptop or your regular system, that's the end. The same result of your friend's laptop blue screening, that is going to be exactly what is going to happen to yours. So you utilize your virtual machine for this because your virtual machine is going to be a very controlled and isolated um environment. So nothing leaks. Anything that happens, the malware can blue screen the virtual machine. For instance, let's say the Windows 10 that you're going to be testing this thing on. The malware can blue screen the virtual machine. If you took a snapshot, you can always go back to the snapshot before it blue screen. And even though you didn't, you can always rebuild the virtual machine. But it's always best to take a snapshot. Now, to avoid um the malware leaking from your virtual machine, because yes, we know that they are virtual machines and they can be isolated. When you don't isolate them, you're actually leaving a door open for whatever malware to leak into your regular system. Though even when the malware leaks, it still has to pass through the hypervisor before it gets to the regular system. So that's another side, and the malware has to be a very, very powerful malware for it to break through the hypervisor and get into your system. So we're going to be talking about the types of network that you can use to ensure that the malware doesn't leak to your host system or leak out of your virtual machine. Now, here you can either use disconnect network, also known as not attached. This is basically your system, your virtual machine is not connected to the internet, it's not connected to your host machine, it's not connected to other virtual machines. It is isolated. Nothing goes out, nothing comes in. Exactly what you that is actually to me that is the best if you're going to deal with a very strong and dangerous malware. I can also use host only. Host only ensures that you can only communicate with the hosts, and you can, but the virtual machine cannot communicate with the internet. Yes, it's communicating with the hosts, but the only way the malware can leak into the host is if you leave your clipboard or your drag and drop will be out. You're going to see the clipboard and drag and drop later in the talk. It's basically like or your shared folders where you share a because once you leave your um clipboard or drag and drop or shared folders on a folder on your host machine that is shared with your virtual machine. Trust the virtual machine. Every single thing that is kept in that virtual machine is going to reflect on the host OS. So that is why it's very important to keep the host to the shared folders turned off, or at least keep it at read only. So there's no way the script or the malware running can run on the host OS. Now, case study two is a disposable browser VM for safety. Like talked about spear phishing emails that get to senior staff of very important companies or see or start the developers are working on specific clients companies. Let's say you constantly get this kind of emails, or you like the curious person wants to run different kind of scripts that you know might once it goes online, it can wreck your system. You can have a maybe your Ubuntu virtual machine for doing that, or your Kali Linux if you're someone that's also interested in the cybersecurity aspect to run all these things and see what actually happens. So when you after you before you do all these things, like I said, it's always very good to take a snapshot. So in case something happens, you can always go back to the good to the previous version of your virtual machine that wasn't broken. So after let's say you click on a link and um it sends a spyware to your virtual machine. You're noticing that the CPU usage of the virtual machine is 90%, almost reaching 100%. You've already noticed that something is wrong. Your settings are being changed. You didn't change the setting, everything is changing. You know that your system has been no, not your system, your virtual machine has been hacked. You can just go back to your snapshots. Or for instance, you forgot to take a snapshot. You shut it out, you delete it, or you destroy the virtual machine, then rebuild it. But it's always very useful to take snapshots. Like I said, I've been emphasizing on snapshots and snapshots. So common virtualization pitfalls. It just happened to me mindsets. This is something that I experienced very well. When I first started out using virtual machines, I actually used a customized version of Kali Linux on VirtualBox. So if the customized version, the regular Kali Linux is about 4 gig. The customized version was about 9 gig. And the customized version, let's say you're downloading it and it's possible the internet cuts for like a second. You have to restart the download from the beginning. It wasn't funny at all. I I wrecked the system over 5 times. I never had a snapshot. So every time the system was wrecked, I had to re-download something of 9 gig over and over again. And most of the time, 5 out of 6 times during the download, the internet will probably cut. So let's say they take lights and the Wi-Fi goes off, and I have to restart it again. So it's the snapshot. The that is a very good question for you having snapshots. Then using VM analysis for malware and during VM for malware analysis and normal dev work. Let's say you have three virtual machines, a Windows 10, a Windows 11, and an Ubuntu virtual machine. Your Windows 11 and Windows 10, sorry, your Windows 11 and Ubuntu are for testing your code compatibility with Windows and Linux. You don't want your those systems to have malware in it. You don't want those virtual machines to have malware in it. And your so what you do is that the Windows 10, since it's even an older version of Windows, you just leave everything you want to do that regarding testing fishy scripts from GitHub or very old libraries and dependencies. You do it on your Windows 10. Also, another mistake that people make is poor network isolation. Using bridge adapter network when you're testing for malware. Bridge network basically gives your virtual machine access to the internet. In fact, it becomes like its own a second system on your system. It has its own IP address. It can connect to Wi-Fi. It can connect to your device hotspots on its own. You do not need your system's IP address or network at all. And you allow it to just roam free like that. The malware once malware enters that system, it can be able to get through to your OS or using hosts only, but leaving the clipboard open and leaving the shared folders open. And the last one is treating virtual machines as permanent. You might say that, oh, it's just like a second system for me. I want to keep it clean. I don't want some this to happen to it. I don't want that to happen to it. The major reason for virtualization is so that you can learn what could go wrong. It's meant to be destroyed, it's meant to be broken, it's meant to be nuked. You're meant to go back to the snapshot or rebuild it multiple times. That's exactly what the virtual machines are meant for. Not for making it sparkling clean like your regular desktop. Now, some best practice for virtual machines, like I've said, taking snapshots before risky actions, using isolated network depending on your security needs. You know when you need to use not attached, when you need to use host only with shared clipboard disabled and drag and drop to the disabled, and also shared folders disabled. You know when your like I've said before, when you're monitoring your virtual machine resource usage, when the CPU is reaching the CPU usage is climbing to 90%, 100 almost 100%, you're seeing that your settings are being changed and files that you never added are there, files that you had before have been removed. Various things are going on that not of your doing. Then you know that somebody has gotten all a malware has gotten into your virtual machine. Um, Separating high risk activities from regular developer work. That is like what I said before. Having multiple VMs um for multiple reasons. Some for malware analysis, some for your regular dev work to test compatibility with different operating systems, and also treating your virtual machines as disposable. Doing everything, doing everything to see whether, in essence, being very very curious, testing all the various script that looks very interesting on GitHub, or running any email that you're not sure that is legit on your virtual machine to see what will happen. Then you can learn from whatever happens on your virtual machine. Because if you don't learn from what will happen on your virtual machine, you're going to learn from what will happen on your real machine. And when something happens to your real machine, it's going to cost you dearly. So the call to action is that virtualization is just a tool for it's not just a security tool. It's actually a security method for controlling risk. Because You might see it as, oh, it's cybersecurity guys since to so that where they can hack from or where they can do it from. Well, no, every developer needs to have their own plan to handle risky code before they need it. You don't wait until you've seen your files on your host OS disappearing before you know that, oh, I should have used it on my Windows 11 virtual machine. I should have used it on the Ubuntu virtual machine. So you have to set these things up before time and learn about it. Learn about it and establish when I say establishing a snapshot routine. Establishing a snapshot routine is that after you downloaded your virtual machine, and you sorry, after you installed it into the hypervisor, you upgrade the all the packages, you take a snapshot. When you're testing dangerous script or malware, before you do that, you take a snapshot. When you're changing settings, crucial settings and everything, you take a snapshot so that you can always go back to the way it was before. And you don't wait for all these incidents to happen, all the malware or the phishing attack to happen before you learn these skills. And like Master Splinter will always say, the best security tool is the one you know how to use under pressure. Not that you have to push um you have to deploy these projects tomorrow. Sorry, you have to deploy the project by this evening or in the afternoon of the next day. And it's 2 a.m. and you're just going through everything. And you see that there's this phishing git JavaScript JavaScript that is a bit JavaScript scripts and a bit weird that you don't know where it came from. And you now want to start downloading what you now want to start downloading your hypervisor or downloading virtual machines that you don't even know how to use. It won't help you at all. So it's best to learn all these tools before you go on, like practice with them, use them just for fun, wreck them, destroy them, and come back to it instead of trying to learn it when you're under pressure. And that's it. And under here, we have resources. Thank you for listening to me. Under here, we have resources for OWASP testing for developers, the testing guide by OWASP for developers, the link to VirtualBox, the link to Parallels for MacBook users, the link to VMware, both the workstation and Fusion. Thank you.
Thank you so much, Mr. Chimereze. Thank you for that beautiful session on evading cyber threats. As